The empirical formula of hydroquinone is C3H3O, and its mass spectrum is given below. Now, the mass spectrum, the largest peak in the mass spectrum represents the molecular formula mass. And you might be able to see it here as 110.1 grams per mole. Okay? Now, we can determine the empirical formula mass from the empirical formula in the usual way. In this case, we have 3 carbons, so 3 times 12.01 equals 36.03. And then we have 3 hydrogens. 3 times 1008 is equal to 3.02. And then we have 1 times 1 oxygen, 16.00 is 1600. So this makes 55.05 grams per empirical formula. So this is the empirical formula mass. Okay? Is everybody clear about how I got it? The empirical formula to the empirical formula mass. Okay, then to use it, all we're going to do is to take C3H3O, and we're going to take the molecular formula mass, divide it by the empirical formula mass, and you'll see 110.1 divided by 55.05 is 2. So this will be C3H3O2. I mean C3H3O taken 2 times. So this will be C6H6O2. C3H6O2, hydroquinone. Does it make sense? Okay, so you're always going to need 2 pieces of information. You're going to need the empirical formula, and from that you can get the empirical formula mass, and then you're going to need the molecular formula mass by some way. Maybe it'll just come down from heaven onto your test question, or maybe you'll have to read a mass spectrum. But that's how it's done. Yes? 55.05, the empirical. Oh, what's this one up here? Oh, all right. I'm glad you asked that question. Okay. You remember we said carbon had more than one isotope? Carbon 12, and then what did we say? There was carbon 13 and carbon 14, and hydrogen had more than one. There's hydrogen 1 and hydrogen 2 and so forth. There'll be some molecules on a percentage basis that have carbon 13, hydrogen, and oxygen.